Alright, this question is kind of vowel substring over string. So you have the substring, and then the vowel substring is, that only consists A, E, I, O, U. And given a string word, return a number of vowels substring a word. So, alright, so again, this is A, I, O, U, and then if the size is equal to 5, right? And then we already know, it has to be set, right? So you're gonna be unique. So if size is equal to 5, we know like this is considered a substring. And then this is also a set of 5, the additional character, so it's still considered substring. So what we can do is that we can traverse, I, so this is I, all the way to what? I minus 4, right? Because when I have a j right here, j is all the way to the end, which is n. So you want to keep another full space, the full index space for another full character, which is vowels, right? And yeah, that's it. So let me dive into the solution, the easy solution you ever seen. So result equal to 0, return result. And I'm going to say for in I equal to 0, I plus 4 less than worst of length, I plus plus. And for every single traversal, I'm going to create a set. So, and I'm going to create j equal to I and j all the way to the last one, and j plus plus. And I need a helper function, public boolean is vowel, so char c. So it's going to be either c equal to a or c equal to e or c equal to I, c equal to o, u. Okay. So if the current character is not, so is not vowels, word chart at a j is not a vowel, then we don't want to consider the substring, right? So we can break. Other side, we just add the current value into the set, and then we can check does the current set size is equal to 5. If this is true, then it's considered substring. Otherwise, you break and then you regenerate a set. Okay. All right. So time and space, all of n times all of n. So it's gonna be what, n squared. This is space all of n. All right. So this is the easiest solution ever. And then if you want to think about the optimal solution, so consider we traverse all of n and then we return immediately. So let's think about this. So again, think about this, like this is what 5 character, right? 5 unique character, and this is also 5 unique character, right? So we can do this. We can find out the at most 5. So at most 5 is like we traverse and then we find out, oh, the current character we have like is currently unique at most 5. But at most 5 is also contain at most 4, at most 3, at most 2, at most 1. So what we need to do is we find out the at most 4, because at most 4 contains at most 3, at most 2, at most 1. So we say at most 5 minus at most 4, and this will only return unique. Unique. UNIQUE, unique 5. So let's think about how I did it. So it's definitely harder, but you know. So I will dive into it. So return at most, the current word 5 minus at most word comma 4. So cool. So public int at most string word string int, and then this will be k. Okay. So we are storing this as a key. And then value is going to be integer. So integers represent um what's that called? What is the current frequency for this? Yes. Integers represent the current frequency because this can be 1, and if it comes here, this index, this will be 2. So we want to calculate the current character with the frequency. And then you definitely need to return an int. Cool. So again, you need a traversal I equal to 0, and also you also need a j equal to 0, starting from the beginning. J less than word start length, and then j plus plus. So what we need to do is we want a sliding window, sliding window to keep on track what is the current substring. And if the current substring is invalid, so for example C is invalid, we want to move the left pointer. So this is the current substring right now. So this current window. So and this is I, this is J. We want to move the current I pointer to J plus 1 right away. And then if this is what, let me think about this. If A, E, I, O, U, I'm just, okay, let me take in the first example. A, E, I, O, U is the vowel windows. So we want to not including the last one. A, E, I, O, U. Okay. So this is I, this is J. We can do J minus I, and then what? Plus 1. This is because it is starting base 0, right? And yeah, that's it. All right. So I will have char C equal to word dot chart add a J. We focus on J when we add, and then we remove I. So when we remove I due to the reset pointer, so if the current character is not val, that will clear the map, right? Clear the map, and also shift my I to J plus 1, and I do the continue because I have a logic in it afterward. But right here is val. Current character is val. So I will say C meta get or default C comma 0 plus 1, just adding the frequency. So while the map dot size is greater than k, so it doesn't matter it's equal or what. So it's greater than k, which means so where is it greater than k? K, yeah, 5 and 4, right? K represent this. So if map dot size is greater than 4, we want to remove the previous one, right? Based on the I pointer. So the value, so this would be 4, this would be 5, right? So what you need to do, this is 4, this is 4, this is 5, right? So 5 and 4 substring are different, right? And technically we want to shift your I pointer to the right. So we will keep on, keep the value window safe, right? Because all of them are considered valid, but the size of the k are different. So char pre equal to word chart added I, and then I will just decrement by 1. So pre, and then meta get pre minus 1, and then I want to make sure my pre, so get pre is the current frequency is equal to 0. I'm going to remove the pre. So if that value, if that key is not valid in a map, I don't want to save it, right? I want to just remove if the frequency is 0. Then I'll increment my I to keep to keep the size of a map equal to the k. And then when I return, sorry, before I continue, so I need to say j minus I plus 1, right? So this will be the solution. So this represent the length, right? And again, like 5 minus 4, they will have an overlap, and then you want to basically delete those overlap, and then you get a result. So, okay, yeah, this is better for sure, but it's harder to understand. But good luck. So time and space, this is time, this is time. So the time for this is all of n, and this could be all of k, so n times k, right? And yeah, that's it. Right, space is all of n, and this is all constant. All right, see you.